Let's look deeper into the concept of the empty set. This is an important idea in set theory. The empty set, also known as a null set, is a set that contains no elements. It is represented in two ways. Either you use this symbol that looks like a /0, or you can use these empty curly braces that looks like this. Regardless of which notation you use, they both mean the same thing. This set has no members. You might wonder, why do we need a set with nothing inside it? Well, it helps us deal with situations where no elements satisfy a condition. For example, if you want to define a set C, but there are no elements that meet the criteria to belong in that set, we can still call it a set, but we say that it is an empty set because there's nothing inside it. Now, what's the number of elements of empty set? Simple. We can say that the number of elements of empty set is 0. In other words, the cardinality of this empty set is 0. Another example here, if we have a set D defined as a set of all odd numbers divisible by 2, since no odd number can be divisible by 2, the set D contains no element. We can write D as the empty set. The empty set plays a key role in mathematics because it acts as the neutral starting point. It is unique because there's only one empty set regardless of the context of subject you're working with. It is the smallest possible set, and any set theory concept can involve the empty set. Now let's talk about the role of the empty set in relation to other sets. First, we can say that the empty set is considered a subset of every set. This means that no matter what set you have, whether it's large or small, this empty set is always a subset of it. We can write it as for any set A, the empty set is a subset of set A. Since the empty set contains no element, there's nothing inside the empty set that could violate the rule of it being in set A, so it's always true that the empty set is a subset of set A. Now, when it comes to the idea of a proper subset, which means that the subset must be strictly smaller than the set is compared to, the empty set is always a proper subset of any non-empty set. Note that the term non-empty. We can write this as the empty set being a proper subset of non-empty set A, meaning that the empty set is strictly contained within any non-empty set. Let's take an example. If set A contains 1, 2, and 3, then we know that the empty set is the proper subset of set A because the empty set is contained within A, but it's not equal to A. However, we know that the empty set is not a proper subset of itself. It is because for a set to be a proper subset, it has to be strictly smaller. However, the empty set is equal to itself but not smaller. So we cannot say that the empty set is a proper subset of itself.